Hurricanes, hailstorms, tornadoes, and wildfires. These are just some of the weather hazards that displace families and disrupt lives. Many of us are familiar with the scenes of devastation these hazards cause, and the recovery process for affected communities can take months, even years. In the most extreme circumstances, some may never be whole again. This may prompt many of you to ask, what's being done to reduce the risks associated with these hazards? To answer this question, the Insurance Institute for Business and Home Safety presents the Disaster Discussions podcast. Join me, your host, Armand Brody, as I sit down with professionals in the insurance, science, construction, and resiliency industries who will help us explore the intersection of these hazards with the built environment. We'll bring you in-depth conversations with experts from across the country and highlight how science is engineering real-world solutions for home and business owners to create safer, more resilient communities. Join us for these discussions every month. And to make sure you don't miss an episode, go subscribe to the Disaster Discussions podcast on your favorite podcast app. We also invite you to engage with us on social media, to ask your questions, share your thoughts, and to learn more about the IBHS mission.
From the studios of IBHS, welcome to the Disaster Discussions podcast. This is your February 2024 episode. Thank you so much for listening in, for watching on IBHS.org. This is a special episode. We're going to be talking about wind engineering, taking all of our research here at IBHS into an operational application of wind engineering with some special folks from the National Weather Service Columbia office joining us. I'm your guest host for today's episode, Christina Gropp, science producer and meteorologist here at IBHS on the microphone. Back with you guys. I hosted a couple episodes back in the very early days of the podcast, and glad to be back here with our listeners and viewers once again. Joining me here in studio from IBHS, Merhi. Ali, great to have you with us.
It's good to be here again. Thank you for having me.
Good, yeah, absolutely. And now we want to welcome in our external guest. We got two special guests with us today from the National Weather Service office in Columbia, as I mentioned. We have John Quagliariello, the warning coordination meteorologist, and Matt Gropp, one of the forecasters at the office as well. Guys, thanks so much for being with us.
Thanks for having us. Yeah.
Well, for those of you wondering how these three gentlemen ended up all together in a podcast, that stems from some severe weather we've already seen this year in South Carolina. In the Southeast, you can pretty much say our severe weather season runs about January 1st to December 31st. Any time of year we can see severe weather. We've already seen that this year. And that brought us the opportunity to build on a collaboration that we really started in earnest last year. So IBHS has been committed now to working more with other sectors of the weather enterprise to help get our research beyond Richburg, beyond the lab, and really interact with folks who can put some of that research into action and who use that research on a daily basis. And that led us to work more closely with some of our local National Weather Service offices here in South Carolina. Last year, we hosted both the Greenville-Spartanburg office and the Columbia office at the lab. Ali, you've been to the Columbia office doing a presentation. We've had a couple of these different interactions, but one thing we said we would do more of is support the Weather Service when we had the opportunity to after an event. And unfortunately, severe weather played out on January the 9th already, and we had that opportunity to accompany both Matt and John out on a damage survey. Ali was one of our wind engineers that joined them. We also had Merhi Morrison and Cora Packerel who went out as well, and that is going to be the theme of today's show. So with that, John and Matt, I want to give you both an opportunity to kind of introduce yourselves and share with our listeners a bit of your background. So John, why don't we start with you?
Sure. Well, thanks for having us. So I'm the warning coordination meteorologist here at the National Weather Service in Columbia. And my main role is to be a liaison between the office and our external partners, emergency managers, media, really anyone that we might use our information in the decision-making process. Also, another part of my job is really make sure partners are prepared for events as we approach a big hazardous weather event. So leading up to and during that event, my job is to make sure they're getting all the information that they need. And then after an event, I'm responsible for all the verification. So making sure, we're verifying tornadoes or damaging winds and working through that whole process again with our partners in collaboration with them. So that's really my primary focus here at the Weather Service.
Yeah, and I'm a forecaster here. So we have currently on station, we have 5 lead forecasters and 7 general forecasters. I'm one of the 7 general forecasters. So responsible for the day-to-day forecasts, warning operations, and things like that. So we do a forecast out 7 days and then do our warning operations day of, aviation forecasts, fire weather forecasts, those kind of things.
Well, Matt, that leads us right into my next question is going back to January the 9th. I believe you were forecasting that day. Kind of give us a meteorological overview of what happened, kind of set the stage. It was a pretty well forecast event.
It was one of the better forecast events I can remember that at least had this kind of impact. We started picking up on the signals that there was going to be a big low pressure system kind of moving into the Mississippi, Ohio Valley, really around kind of the start of the new year. So like 8-9 days out, kind of started to see the signals, which is extremely far into the future for this type of event. And then as we got closer, there was a lot of signals it was going to be a fairly extreme environment that set up. We had that really strong low pressure into the Ohio Valley. And then we had a really, really strong high pressure system off the East Coast too. So usually you don't get those two things lining up at the same time. So the pressure gradient that set up kind of between those two systems was the strongest we've ever had in South Carolina, at least for a 12-hour period. And because of that, we had a very, very strong southerly wind, a lot of wind shear that set up. And this was all pretty well forecast, day 4, day 5. So we started messaging that this was going to be a pretty impactful event. And then we kind of had a typical cold air wedge that sets up kind of on the east side of the Appalachians. When you get that high pressure system off the East Coast, usually the system's not strong enough to, at least the low pressure system's not strong enough to kind of scour that wedge out ahead of it. But in this case it was. So that wedge kind of pushed north and we were left with some fairly juicy air across South Carolina with a lot of wind shear. And we knew going into it, we were going to have a lot of just regular gradient wind. So the winds out in front of the front were really strong, gusting up to 60 miles an hour pretty much across all of South Carolina. We also knew there was going to be a tornado threat. We didn't think it was going to be a big outbreak day where we were going to have multiple, long track tornadoes, but we knew if we did have tornadoes, they were going to be pretty strong like we saw in Bamberg.
That was a pretty unique environment with those gradient winds across such a broad area.
It was. It's right up there with Hurricane Hugo and the superstorm of '93 in terms of the pressure gradient that we had, especially from pretty much the Gulf of Mexico all the way up to the Mid-Atlantic had that really, really strong pressure gradient. Really rare and set up for your classic high shear, low cape kind of environment for us.
So, John, on a day like that, what does your role look like in terms of working with partners and making sure that message gets out from the National Weather Service?
Sure. So like Matt had said, we saw signals for this well in advance. So really we want to make sure we're communicating that and we're trying to get our confidence levels out. It's rare that we see something like that, like Matt was saying, almost a week out ahead of time. So we start letting our partners know, hey, look, we have something a week from now. We think we might have strong winds, potential for severe weather. They know this is maybe something that's not typical. We have higher confidence in this kind of event. So one of the big things that we do is make sure our partners are getting all the information they need to make proper decisions. So the impacts, timing, all that's really important. And, not only was it a severe weather potential, which was highlighted by the Storm Prediction Center well ahead of time, but we knew the winds were going to be strong. That has an impact on school buses here in South Carolina. So we were talking to county emergency managers, school districts, school superintendents, making decisions on schools days ahead of time. Of course, we cooperate a lot with our media partners and everyone else to make sure we're all on the same page, communicating the same way and the message is the same, so everyone takes necessary action. And then during the event, it's making sure that everyone's aware of what's going on, the seriousness of the situation, on the phone with emergency managers as we have those tornado warnings going out, giving them a heads up, trying to get damage reports. So there's really a whole lot going on, but one of my biggest things is to make sure that communication is there and people are getting the information that they need.
Yeah, and it's such a vital piece of the weather forecast is getting it out. Just like we talk about communicating the research, communicating the forecast is probably even more important as that's what impacts everyone each and every day. And those are messages that we strive to amplify at IBHS too, as a Weather Ready Nation ambassador from the Weather Service, making sure that we're all singing that same song, telling people the same messages, especially in those last few days up to an event. So we had the storms kind of play out that afternoon. And the next day, it was time for the damage survey. And you guys from the Weather Service were the two on the Bamberg survey. John, can you kind of describe that process? I mean, you mentioned getting some of the reports from emergency managers during the event. Kind of what is your process for a damage survey like that?
Yeah, so it's a really important process to really know what's going on. So we go out, and the first thing we want to do is determine was the damage result of a downburst or straight line winds, or was it a result of a tornado? And for that, we really look at the way the damage occurred. So for a straight line wind, or what we call a downburst event, typically all the damage will be down in one direction, which is really the direction the storm is moving, or might have a slightly divergent path. You might see trees kind of spreading out away from each other. That's a sign of a downburst. With the tornado, you're not going to quite see the same thing. You're either going to see the damage kind of convergent toward the path of the tornado or toward the track of the tornado, or you actually might see things moving in opposite directions or cross track. So we first look for that. And once we determine that it was a tornado, which we did in this case, most of the damage was in one direction, but we did see some signs of convergent pattern of trees and some roof damage, which showed inflow pretty much into that tornado. Once we determine that it was a tornado, we have to determine start and end points. We get a path length. We have to determine the maximum width of the damage. And then we have to come up with a peak intensity. And for that, we have to look at various points along that track, assess the damage, and come up with a rating. And that's what's used to essentially rate the tornado. So it's a lengthy process. We have to talk to witnesses that are out there. We have to have eyes on the ground at the damage, a lot of driving, a lot of walking. We could be out in the field for hours looking at the damage. And we come back to the office. We need to assess what happened out there, look at radar, make sure everything kind of matches up, and then we plot it all out in pretty much a GIS system with our photos, and it makes all the information available to our partners. So it's pretty much an all-day process doing these storm surveys. The media, everyone wants to know what happened. So people oftentimes want information while we're out there, and sometimes it really takes a lot of analysis back in the field and in the office to really determine what happened. So a lot of times we can't get that survey complete until later that evening, or sometimes even the next day.
All right, so that's where I want to bring in Ali. Ali, you were one of the three wind engineers that got to accompany Matt and John out on this damage survey in Bamberg. And while your research has done a lot with damage surveys and you've looked at a lot of damage, this was actually your first time being able to be on the ground right after an event looking at the damage. The unique pandemic circumstances drove that, but how was that for you as a wind engineer?
Yeah, I mean, before, during the pandemic, I was always looking at damage using street level imaging. So I used to be sent the images of the neighborhoods and all that and build, like street view and then navigate, and then you look at the figures. But it's completely different when you go there on the day or right after, because first of all, you can't pretty much collect figures on street level imaging because the roads are still closed. Trees and power lines on the ground is pretty dangerous, so you need to be aware even when you walk, so you can't even drive. And you see actual debris that's still there that needs to be lifted, and you see actual all the entities, the emergency management working on removing those. And as scientists or engineers, we see in all those pieces that came off the building, or sometimes the building that crumbles or destroyed, we see a lot of indicators or evidence that could lead to a potential scenario that the building followed while it was being damaged. So it's a valuable source of information, and it's a time-sensitive thing. Like the earlier you get there, ideally you'd be there during the storm, but it's unsafe. So the earlier you get there, the more indicators you have that are actually perishable with time because they will be removed. So as soon as I got there, I was a little lost because there were so many evidence here and there, and I had to figure my own way to build the track.
And that's part of I think the challenge for folks like Matt and John every day is there's so much damage. What do you look at first? Exactly.
So we got some piece a little bit about what Matt and John do when they go to the storm, and that actually is really valuable. I can speak for myself and as a researcher at IBHS, because this way we actually relate to the damage that happens there to what we see here, and with the collaboration with them, we see also like, the applicability of post-disaster investigations, what the logistics look like, and what the process is, like how long it takes to evaluate. And, for tornadoes, we use the EF scale, so also the applicability of that. So that was really valuable, at least to me from my end.
So in this particular instance, there were buildings damaged, and in South Carolina, we see a fair number of tornadoes that only damage trees. So Matt, I know this was your first opportunity you had to survey a tornado with buildings damaged. Talk about that experience and how that kind of shifts perspectives a little bit.
Yeah, so it's kind of why I wanted to go survey this event, because I had not seen structural damage in person. Fortunately, there was no one injured or killed with this, despite it hitting some fairly substantial structures in Bamberg. But yeah, I'd only seen tree damage. I've seen EF2 and EF1 tree damage before, which is pretty impressive in its own right. But when you see what we saw in Bamberg, it was kind of sobering to like a barrel factory completely destroyed and a couple buildings downtown that were knocked over. Definitely sets a different perspective there. And with these kind of tornadoes that we were expecting, that they're moving at 70 miles an hour, 80 miles an hour maybe, with that really, really strong low-level flow going on. So the damage itself kind of looks like straight line winds at first, and then you start looking for those little pieces of damage, like, oh, this insulation was pulled back on the inside of a fence. That couldn't happen with straight line wind damage. It can only happen with a tornado. Or these shingles on this roof were only blown off on this one side that would be inflow to the tornado. Again, things that just wouldn't happen with straight line wind damage. So it was interesting to see the dynamic and the connection there between the wind damage and the structures versus what I'd only seen with tree damage before.
And you mentioned that barrel factory. That was a unique building that, Ali, I know you spent a good amount of time looking at because of how the factory came to be. It was an old automotive building with a new metal building attached to it, which then presents a challenge when you're surveying it because you have two different eras of construction, two completely different style constructions. And Ali, from your work on the EF scale, that's not a perfect building that is listed out in the EF scale.
Yeah, so, and also like from what the owner was telling us, it used to be, I think, a car dealership, and Matt and John, please correct me if I'm wrong, because I think you were there too.
Yeah.
And it was at some point attached to another building, which was more of a steel portal frame building. So if you look at them separately, the old one can classify as, like an old building that is, more retail or small professional, depending on the case in general. The other one is more of a steel frame system. So those are completely different damage indicators. And then they were united. So,
and then reality.
Yes. So it's not a building that you see, like a la carte, and you choose from the EF scale, like based on the damage indicator. You have to look a little bit at where the damage happened exactly. And, we saw more like what the damage was. It was not the steel building. It was the retail or the smaller, older building. And being there helps a lot on actually identifying those differences. So it is a challenge about identifying not just so to get to the wind speed or the EF, there are a lot of milestones that you have to achieve. Like, first of all, you need to identify the type of building, and that's what we mentioned. Then you need to identify the type of damage that building sustained. And that's also an even more complex or detailed damage because, you need to look at all the angles of the different sides and see where actually the biggest or the most severe damage happened. And while you're there, you have some more information. You need to look, or at least your inquisitive nature leads you to look into those, to just try and understand and build a more accurate scenario that the building followed to being damaged. And by doing that, you can also establish some resistance level that defines, how weak or strong the connections were between the different components of the building. And by doing that, you lead up to the wind speed that caused the building to fail. So it's not, there are challenges, but, they come up, and gladly, when you look at the applicability of the EF scale, it does play a good role at doing that. But we are even working on improving that to be even more accurate or let's say consistent across whoever uses it. So,
but we want to talk a little bit more about that. But while we're talking about the barrel factory, there was a great story coming out of that in terms of the communication side and the warning process that worked. Matt and John, do you want to share a little bit about that story and that positive that came out of that?
Sure. So we talked to the, I believe it was the building manager at the time. And, we were concerned there were people in the building, given that most of it was just totally destroyed. And he said, they had sent their employees, I believe it was 20 employees there, or maybe even more, home earlier in the day because of the forecast. So even though the warning pretty much came out just about the time the tornado was touching down, we didn't have a whole lot of lead time like we typically would like to for this tornado. People were aware of it. And I think that was, again, because we were talking about earlier. We saw this event potentially 7 days out. It was getting a lot of media coverage. A lot of people were just prepared for it. So here he sent the staff home early. And because of that, very well could have saved some lives. So it's, people hearing these forecasts and taking, precautionary measures well ahead of time is really what ultimately, I think, saves lives in these kind of matters.
Yeah, absolutely. It was such a great story to hear that the process worked. And that's what we always hope will happen, even though you don't like to end up surveying the damage after the fact. But John, I'm interested in your perspective. You've been on quite a few damage surveys in your career. What about having Ali and wind engineers kind of accompanying you on a damage survey? How does that help? How does that benefit you guys? Because you're used to doing this all the time without us, but it was a unique opportunity for us to join you.
Sure, yeah, absolutely. And first, our partnership, I think, is just incredible. What we've been able to do here in a short amount of time, and already seen the benefits of it. And I think, I'm not an engineer. I'm a meteorologist. So we kind of learned to do surveys on the job. And we have the EF scale, which is kind of meant for people that aren't engineers, kind of to help guide us a little bit. I know we'll probably talk about this a little bit more later on, but having an engineer there to actually see what they're looking at, to see the failure points in a building, kind of just builds up my knowledge and our knowledge as an agency. So when we have future surveys, yeah, I remember seeing that. That's the reason why that happened. That's why it failed there. And like Ali had mentioned, in this case, we had a building that was kind of two different structures built at different times. And even in downtown Bamberg, we had historic buildings from the 1800s with roofs that were just recently put on. So, what was the failure point? What was the cause of it? And the more we see this, the more we get experienced engineers with us to kind of point things out. It really allows us to do a better job in the future. Now, the interesting thing is all of you at IBHS are researchers. So Ali and the team are out there really studying those structures for a long time. Me and Matt, we've got to go. We got to figure out this whole track, how long it is.
Got to do a media interview.
Yeah, had media interviews, press conferences. So it was great that the researchers could focus on those structures, and we were able to kind of go see the damage and kind of move on. So it just kind of shows the difference between the research side, I think, and the operational side. But it makes us better as operational meteorologists to have the expertise of engineers there with us. We really appreciated that.
It definitely is a stressful environment when you have to, being tailed by press and media, and having, to achieve all those investigations and get all the results out by the end of a specific time. I kind of saw that. And yes, it's like you need to be also, build your own view of what the damage was like. So you want to take your time, but on the other end, that is not completely an infinite resource. So and having more and more experience, not just in being there, but also in looking at those complex issues, like having different buildings. I think that can be solved. I think at some point if we make a better standard, and as engineers and scientists, we are always actively working on that. And that gives us an idea about how we can come together better at providing these kind of investigations, and ultimately it would be good to have it right away as an accurate visual without spending too much time. And like I said before, it's sensitive. People need to get back to their community as soon as possible, and we can't spend all the day.
Part of what you did when we were out there, Ali, you and Cora used a LiDAR to capture a point cloud of what was happening. Talk about why that benefits you guys so that you can kind of continue work.
Exactly, to that point, because we cannot spend all the time there looking at the building. So what the LiDAR does is it's a point cloud system. So you put the LiDAR there and scan, and it takes exactly everything that the light reflects upon it. So it's like a time saving thing, and it actually takes a snapshot in time of everything it sees. So this way, when we're looking at the LiDAR scan of the barrel factory building, for example, we can go and take a look at least the dimensions. So we can look at those bays, and we know how many frames actually failed because we went and looked at the debris. So we know they were like about 3 or 4 rafters. I don't have the exact number off the top of my head, but we can get that measurement from the LiDAR point cloud because it's a space saving, so we can get the measurements, all of those, with the scan. And if anybody wants to investigate or do scientific research out of it, we can actually look and try and estimate what could be a wind loading that caused that building to fail. So it's really a good way to store the data in a reliable manner, because no matter when, you can go back and access that kind of data and look at them again. And the building hopefully will get back to business as soon as possible, this way without having other people, walking into and wanting to investigate further. So I think that was a valuable source.
Yeah. Any other observations from the ground while we were out in Bamberg from you guys, Matt and John?
Sure. I think it kind of go into the operational nature of us doing the surveys. Like, we don't have all the time in the world, especially with something like Bamberg, where the optics of it looked, I think, worse than the damage was potentially with how it fell in downtown Bamberg. There's bricks all over the street, and people wanted answers as to what did the damage, whether it was a tornado, whether it was straight line winds or whatever. So yeah, you are kind of time crunched on that whole process, which was interesting. And in the middle of it, John's doing a press conference. And yeah, as Ali said, it is sort of a stressful environment.
Yeah, I just think, this was just one tornado. Sometimes we have outbreaks where there might be 6 or 8 tornadoes, and it does take several days to do that. But I like to think of these kind of as like being a detective almost, because, radar might show that we had a tornado. First, we have to confirm that, and then we're really putting together all the pieces. We don't have all the knowledge, We found one building was destroyed, and we later found out it may not have had a roof on it. So, the more you find out, the more the puzzle starts coming together. So it really is, we're working with a lot of missing information. Structurally, storm-wise, was it a tornado? How large? Was it multiple tornadoes? So you're trying to put all these pieces together, and whatever we do out there, we're probably never going to get it exactly right. I mean, different meteorologists can see different things in there. So our job is to be as consistent as we can and do as thorough of a job as we can at the time that we have. But again, any kind of assistance we can have with engineers and other people to look at the data really kind of helps ensure that what we're putting out is accurate information.
And I think that's a great point, John and Ali. Something you've talked about is that the EF scale kind of helps everyone across the weather enterprise, from folks like you on the engineering side to folks like Matt and John out in the field, put you all on the same page about damage.
Yeah. So.
And you got to see that.
Yeah, and I remember I was doing some measurements, taking some measurements with Gropp and Merhi and Matt and John, and we're looking at the damage on the different building. And then at some point we crossed paths, and they were talking about classifying some damage, and I was like, yeah, that looks like, yeah, the right, I would classify it the same way. It looked like we were using the same language. So no matter, even if John just said, you don't have the structural, but I think, it was there and you classified it the right way. So, and that was really nice thing, bringing us with the expertise that we have. And that was the objective of the EF scale, to eliminate the human factor actually out of it. And based on if you have a scientific background, you can actually, use that as a scale, no matter what the background is. And that was the ultimate objective of having a consistent, objective EF scale without allowing any chance for misinterpretations. I would put it this way. Yeah, so I think that was a nice experience. I don't know much about meteorology, but having you and us complete the circle of investigation and actually connecting the swath to the damage. And I'm a learner, so I go and access every now and then the data and look at the swath and see where you guys place the different points and documenting the track. And I think this is fascinating because ultimately for us, it's really important to connect from radar readings actually to an expected damage or at least the wind speed that can happen because of that swath that you already are trying to forecast.
And John mentioned, kind of being forensic, putting the pieces together. That's something you don't necessarily have to do here in the test chamber when you're running research testing, because you get to watch that cascade of failure, whereas when it plays out in the real world, you're putting the pieces together after the fact. Exactly.
And, as I was saying, that over there is more after a natural hazard, which is a combination of, from meteorological aspect to the boundary layer of the wind field to actually the damage itself. And I think here was the value, at least personally to me, because we look at damage here all the time in our chamber in lab conditions, and we try to simulate as much as possible the real wind field that you see out there. So when you actually see the damage mode happening out there that is compatible 100% with the failure modes that you see in the lab, this gives us reassurance. And it's an opportunity also as scientists to keep an eye to make sure that we are not missing out on any concept that might be there that we are not aware of. For example, garage doors. We saw some garage door failures, and I remember one of them that was in front of the barrel factory. It had the roof popped up, and this is something that we expect to see, and we know why it happens. So that was as a wind engineer, and even for the barrel factory itself. When I saw the owner, the first question that I asked him was, "Did you hear any window or door breaking?" Because the way that the damage happened, the roof being lifted like that, one of the possibilities is if you have a sudden jump in the internal pressures, and it turns out it was this. This is what exactly happened. So it's really interesting to see, for us at least as scientists, results in simulated conditions matched with the reality.
No, you talked, Ali, about you thought the EF scale already put you and John and Matt and folks in the Weather Service on the same page, yet there is an effort to make the EF scale even better, and you're a part of that effort.
Yeah, so there has been a lot of work ongoing for quite a while, even before the pandemic, and multiple entities and people, academics from industry, and all different entities are working on this. And I got the privilege of working on it to see actually how we can improve the scale and to see how to remove any subjectivity out of it. And really, we used a drafted standard to see how it would apply compared with the legacy EF, which is currently being used. And there are many interesting things that will hopefully lead to even optimized consistency to eliminate further the subjectivities or the challenges that can happen. For example, like in rural areas, there are less and less buildings. I mean, in our case in Bamberg, it was a town, but if it happens in the middle of nowhere where there are very few buildings, now there is a damage indicator that is a church or, some things that you might not see in very heavily urbanized areas. So there is that, some addition filling the gaps of damage indicators. There are others which, for example, seek to improve the way that you classify damage itself. So, for example, in a single-family house, a threshold of damage, especially in the lower range of severity, where percentage of roof coverage. For example, if you have asphalt shingles. And on the current one, it's, if it's less than 20%, it is a degree of damage too. Now it's more of a fraction, so it became more like less than a quarter, between a quarter and a half. And for people, we are not computers, so when you're standing there, it's hard to see if it's 20% or less, or if it's 25% or less. It's easier for us as humans to see a quarter or a half. So kind of helps with that. Now, for AIs or computers, that doesn't matter.
Yeah.
But in a lot of cases, when you are pressed with time, you are forced to actually use the scale, and you need to produce some accurate assessments. So that's that.
Now, just so that's all in the future, and that work
Yes.
is ongoing. Our podcast listeners may remember back, we had an episode early on in the podcast with Dr. Tanya Brown-Jamanko and Jim Ledoux from NIST and NOAA talking about that EF scale work. So I encourage you to go back, take a listen to those episodes if you're interested in hearing more about the evolution of where that might go in the future, that might change this kind of process in the future. In terms of the EF scale right now, Matt and John, kind of what challenges do you guys have when you use that? Ali thought, of course, you guys did a great job when we were out there with you in Bamberg, but what kind of challenges do you guys run into with it?
I think first, always determining the damage indicator could be difficult. It's not always straightforward, right? What is this building considered?
Yeah.
You don't always have things on there, like Ali had mentioned, maybe adding churches. In the case of this automobile dealership, what is the proper, or former automobile dealership, what is the proper damage indicator to use? What happens when you have mixed construction types? Like I said, we had buildings from 1800s with newly built roofs on it, which had failed. What was the cause of the failure? So first determining that. And then the EF scale, I mean, it's kind of made for, I want to say engineering idiots in some ways, right? Because, I mean, you don't have to have thorough knowledge of it. It's essentially, you assume it's average construction. It gives you a rating for average construction looking at the damage indicator and the degree of damage that occurred. So we assume average, and then you try to find signs that it was either above average construction, was it something built in a hurricane zone where we know there was extra reinforcements? Maybe was it older construction built to older code? Or you have to look around a little bit. How was the foundation secured? All these different things that we kind of have to look for, and I really don't have a ton of knowledge, but I can tell, yes, this looks like it's probably similar to all the other homes around it, or this one, look how that roof was attached. It doesn't look like it was on very secure, and we could kind of adjust the ratings on there, and I think it's pretty remarkable. I think we kind of came up with our own assessment in Bamberg, and then we asked folks from IBHS, what did you come up with wind speed wise? And we were probably off maybe 10 miles an hour or so, 15 miles an hour on the ultimate ratings in various locations. So I think it shows that the EF scale does what it's supposed to do. It may not be exact, but I think it gets us in a ballpark. And I think that's really the intent of it, because we don't have, like we said, a whole lot of time in the fields. We're looking quickly. We don't have the engineering expertise, at least most of us don't, that are out there. So it's something to provide us a quick look, a quick estimate that's fairly close, that someone, just with a meteorology degree go out there and really use. And it's nice to see that what we're coming up with is fairly close to what the engineers are seeing as well. I mean, Mal, what's your take on that, using the scale?
Yeah, I guess seeing structural damage for the first time. I know the new EF scale for tree damage is going to be much better. I'm not as familiar with the structural side of it, obviously, being the first time I saw structural damage with this event. But yeah, I think it does put everybody on the same language, even if it can be improved in the future, which is going to be great. But yeah, I think it generally works pretty well. We tend to be, I think we were a little bit high on our ratings relative to what you guys had in terms of wind speed, which was, I guess, to be expected, with a less critical eye from John and I in terms of how things were built and stuff like that. So
I think one of the interesting buildings, John, that you've mentioned a couple of times, the old building in downtown, retrofitted with a modern roof, but the roof still failed. And Ali, one thing that we saw on the ground, those connections that we talk about all the time, the connections matter so much when you're tying the pieces of those structures together. And those are the tiny little details you all are looking for when you're on the ground to know what kind of nails, what kind of bolts, though that's what matters. I mean, in fortified, we talk about down to, is it a square washer or a round washer? That matters in terms of the wind resistance.
Right, because if you have something basically with no connection, it's kind of like a sitting duck. It's just waiting to be picked up. And the wind speed that will cause that is definitely going to be much slower than if you have regularly, or at least a stronger connection, or even like according. So the best connection is the one that actually preserves to the design wind speed as the building is designed for when using the ASCE standard, the American Society of Civil Engineers standard, which says this building should not fail, or this connection should not fail unless you have a specific wind speed, right? And the connection is designed based on that. And we know what the connections at least should be to meet the code. So when we see a lack or an inconsistency of those connections, it's normal or expected that the wind speed that would cause that failure is going to be less than the design wind speed that is provided in the code. So those are very important indicators. And sometimes the older that the building is, it means that the building was designed to a previous code era, right? And in a specific time there was a shift. So we kind of here at IBHS, we are aware when those shifts happened. So we kind of know when a building has a relatively better design than it was, especially like after the early 2000s era.
And we're only just now seeing into ASCE 7 the tornado wind load. So we're only just now going to start building buildings to withstand. And even then, it's only a small subset of buildings, but that's a whole different podcast episode that we could go down with Merhi. But I think we've covered a lot here. And Ali, to kind of wrap up, you started mentioning it a couple of times, but how does being on the ground with folks like John and Matt help further some of our work here in the lab that you're doing on the wind side? I
think this is a very fruitful collaboration. At least this was the very first application of, like you mentioned at the beginning, and it's a nice way to close the circle. We did have a meeting with the fellows from the Columbia office and from Greenville and Spartanburg, and we discussed actually how we can collaborate, seeing that our lab is actually in the area, in proximity, which gives us the logistical flexibility to actually go to the ground whenever a disaster happens. So doing that, like from the data that we collected, for example, we did store that in a repository, and right now, like I can give off the top of my head the example of the garage door that I gave. We did a lot of work on garage doors in the past, and right now we are at a mature stage on developing some kind of recommendation to improve building design, especially for buildings that do have flexible doors. And that is something that is typically not seen in a scaled models in the wind tunnel, but we saw that in our full scale chamber because we replicate the components as they are with their flexibility.
The full system.
Exactly. And that's very important because, when you see this damage, and we saw it in different events, after Hurricane Ike, after Norman tornado, and also more tornadoes. So this is something ongoing, and this is from the deployment in Bamberg. This was a confirmation that this is a consistent type of damage, and it needs to be resolved upstream. And I'm really looking forward to collaborating further. There are some different aspects of collaboration that can happen. For example, we did talk one time in a podcast about the PIP tower that measures the precipitation that happens in a hurricane. We are looking forward to actually compare the measurements that the PIP or the precipitation imaging probe does with what other gauges do, like a rain gauge, tipping bucket, or Percival, and actually see what the effect of wind speed can have on each one of those sensors regularly. And I imagine National Weather Service uses a lot of rain gauges. So I'm looking forward to also having a conversation on that. And the conversations keep going and going when you establish some kind of collaboration.
Matt and John, I want to offer you an opportunity to provide any last thoughts kind of on Bamberg and our partnership. And we want to say we really appreciate our work with you guys and look forward to continuing it.
Yeah, I think this is great work. I mean, one, kind of bringing research to operations and maybe the other way around as well, I think is really critical. But I think we also have talked about ways we could work throughout the year of just getting public messaging out in terms of safety messaging and how wind can have an impact on structures. And so I think there's a lot of ways we could collaborate together. So I'm really looking forward to that. I think this is just really start of what could be a really good relationship, beneficial to both. And, I think, hopefully we don't have to do too many of these surveys we have structural damage, but it does happen. And knowing that we have the resource of IBHS up there that could potentially come out and and help look at things with us. That gives us a little more confidence that we're doing an accurate job when we're surveying. It helps, teach us as meteorologists what we need to be looking for a little bit better. So I definitely feel more comfortable next time I'm out on the storm survey without an engineer with me, because I already kind of know what to look for and I've seen things. So I really just think that the ability to train and learn from each other is just really beneficial. I feel a little more comfortable too, knowing that maybe the way we've done things is pretty good, knowing that, talking with engineers and seeing the EF scale working properly, that maybe our ratings are pretty close to what they should be. I always worry sometimes, we overestimating, we underestimating, and just don't know. But to know that we're using the scale the right way and we're coming up with roughly the right numbers, leads to some confidence that we've been doing a good job with these surveys, and hopefully just get better at them now, the more experience we get working with each other. What are your thoughts on that?
Yeah, sure. It was super insightful hearing Quagliariello and Merhi just kind of like nerd out over structural damage, which was very interesting. Just the stuff you guys look for in the dispersion of the debris, the failure modes, and stuff like that was super interesting. And yeah, again, hopefully we don't have to do these too many times, but unfortunately it's inevitable that we'll have this type of damage in the future. So looking forward to it, tongue in cheek a little bit going forward.
And definitely gives me confidence also. It's not one way. So like the tree damage, for example, right? Now I am a civil engineer. I'm not an arborist, but looking at the current EAF, for example, we do have softwood and hardwood, right? And I do have some knowledge about trees, but I can assure you, if I get deployed somewhere in the Midwest where there is a specific species of trees that I don't know, that would cause some trouble for me classifying that. And that's something that is being addressed also in the next one. Like in the updated one, the trees will be classified based on a different parameter that is measurable, which is diameter at breast height. So that's something more of a measure than actually of nature.
That learning continues back and forth from folks in operations to folks here in research. Connecting the dots, that's the whole goal of the Disaster Discussions podcast. That's so much of our work here at IBHS, and I think a fantastic place to wrap us up for today. We thank you so much for joining us on the Disaster Discussions podcast. Remember, you can always find us on all your favorite podcasting platforms, and be sure to tune back in next month for the next episode. We want to thank once again our guests from the National Weather Service, the Warning Coordination Meteorologist, John Quagliariello, and one of the forecasters, Matt Gropp, along with Ali Merhi, one of our research engineers here at IBHS. I've been your guest host for today's episode, Christina Gropp. Thanks so much for joining us, and we'll see you back here next month.
Thanks for listening to the Disaster Discussions podcast, an IBHS production. Subscribe to our podcast on your favorite podcast app, or watch the podcast on our website at ibhs.org/Disaster Discussions podcast and the Insurance Institute for Business and Home Safety YouTube channel. Connect with us on our social media pages on Twitter at Disaster Safety, Facebook at facebook.com/Disaster Safety, and on Instagram at IBHS_org. For more great content from IBHS, including ongoing research efforts happening at our facility, episodes of our podcast, and more, visit IBHS.org.